Hello! In this video, we'll show you how to recover data from software RAID 5 and RAID 0 arrays created in Server Manager through storage spaces on Windows Server 2022. You'll learn how to quickly recover accidentally deleted files or regain access to critical information if the server fails, a drive stops working, or the system simply stops recognizing the array. To handle these tasks effectively, we'll use Hetman RAID Recovery. One of its major advantages is full cross-platform support. You can connect problematic server drives to any convenient workstation and recover data not only on Windows, but also on Linux or macOS. WSS RAID Features. In Windows Server 2022, software disk arrays are created using storage spaces in Server Manager. This modern storage virtualization system works by creating pools. First, physical drives are combined into a common storage pool, and virtual disks are then created inside it with the required level of fault tolerance, such as simple or parity arrays, corresponding to traditional RAID 0 and RAID 5. This approach provides flexible capacity management and highly scalable server storage. Another important setting for virtual disks in storage spaces is the provisioning type. The system offers two options, a thin disk called thin and a fixed disk called fixed, which technical specialists often refer to as thick. Fixed immediately reserves the entire capacity on the physical drives, while thin allocates space dynamically as files are actually written. In our example, we use both options. The parity array was created with fixed or thick provisioning, while the simple array uses dynamic or thin provisioning. Regardless of the selected type, Hetman RAID Recovery can recognize the structure of both configurations equally well. Another important detail is that both our arrays are formatted with the modern REFS, or Resilient File System. Hetman RAID Recovery supports a huge number of file systems, including REFS, so regardless of the provisioning type or the complexity of the architecture, its algorithms can recognize their structure equally effectively. The key feature of this technology is that the array configuration is stored as metadata on the drives themselves, rather than in the operating system. This makes it easy to move drives between servers, but it also creates certain risks. Any operating system failure or metadata corruption can instantly destroy the pool, after which Windows displays the drives as unallocated. Recovery access with standard tools becomes impossible. However, Hetman RAID Recovery automatically scans the sectors, finds the remaining storage space's metadata, and virtually rebuilds the array for safe file recovery. BitLocker disk encryption. Another important aspect is the use of BitLocker technology, which protects data by encrypting it at the sector level. If the virtual disks in your array were encrypted, you will need a 48-digit recovery password or a key file in the BEK format if access to the pool is lost. Since the information is encrypted at the physical level, the volume must first be unlocked directly in the Hetman RAID Recovery interface before the program can search for files. Only after the protection is removed can the algorithms analyze the logical structure and find all the lost data. Connecting the drives to a PC. Before starting the recovery process, you need to remove the drives from the problematic server and connect them to your workstation. The best and most reliable method is to connect the drives directly to the motherboard through SATA ports or by using additional SAS or HBA expansion cards. This approach provides maximum read speed and ensures stable operation during the analysis. There is one important detail worth mentioning. Since our test scenario uses a RAID 5 array as an example, you do not necessarily need to connect every drive for successful assembly and full data recovery. It is enough to connect the minimum required number of working drives, and the program will automatically calculate the missing data using the parity blocks. Working with disk images. There are situations where it is physically impossible to connect all the required drives at the same time because the computer does not have enough available ports. In this case, you can use the sector-by-sector imaging feature. This is also considered the gold standard for safety when working with drives showing signs of hardware failure or bad sectors. An image is an exact byte-for-byte copy of your physical drive, saved as a regular file on another storage device with sufficient capacity. You can connect the server drives one at a time, create images from them, and then simply load all the resulting files into Hetman RAID Recovery. The program will work with them exactly as it would with real physical devices. To create an image, launch the program, select the required drive, and click the Save Disk button on the top panel. Then simply choose where to save it. Keep in mind that the size of the resulting file will match the total capacity of the original drive, regardless of how much data is actually stored on it, so make sure you have enough free space. Once the saving process is complete, open the main menu and select Mount Disk. From the available options, choose Raw Disk Images and open the files you have just created. They will immediately appear in the list of available devices. The program is now ready to automatically assemble your array. Automatic RAID Array Recovery. Once all the drives have been successfully connected to the workstation or their sector-by-sector images have been mounted, we launch Hetman RAID Recovery. The program automatically analyzes the structures and immediately recognizes the parity and simple arrays we created earlier. In our test setup, we can see that the software parity array is successfully rebuilt automatically, even though one of the drives is physically missing. This once again confirms that for full data recovery, it is enough to connect the minimum required number of active drives, while the utility calculates the missing data automatically using the parity blocks. Since our test virtual disks were previously encrypted with BitLocker, they must be unlocked to access the files. And here we should point out an important technical detail that explains why we perform this step specifically in macOS. If you connect the server drives to a regular Windows computer and try to unlock the array using system tools, background processes will immediately create hidden folders and update the metadata. This almost always results in partial overwriting of the lost information. By working on a Mac and unlocking the volumes exclusively in the safe Hetman RAID Recovery environment, we completely avoid this risk. The program supports 3 convenient decryption methods: entering a regular text password, using a 48-digit recovery key, or loading a special BEK file. In our example, we choose the simplest option and simply enter the password. The utility then automatically removes the protection and provides access to the volume. However, if you have already tried to open your problematic drives in Windows before watching this video, the file structure may have been modified. In this case, the basic fast scan algorithm, which we are about to use, may not be sufficient. You will need to run the full scan function. This method performs a deep byte-for-byte scan and can effectively find data with unique signatures, even after partial overwriting. Now we move on to the final stage. We click on the assembled and unlocked array and launch the fast scan algorithm. After the quick analysis, the program correctly recognizes the logical structure of the REFS file system and displays all the detected data while fully preserving the original folder hierarchy for safe recovery. Recovering deleted files. Although the original data was created in a Windows Server environment, the program easily works with dozens of different file systems and successfully handles the specifics of our REFS-based volume, correctly recognizing the original array structure. In the results window, you will immediately see the entire file system with existing and deleted folders. Data that was lost before the critical array failure can be easily found in the list because it is marked with a special red cross indicator. Before recovery, you can check the results using the preview mode. The preview function allows you to instantly open the contents of any document, photo, or database to make sure the files are intact. To recover the detected information, select the required items and click the Recovery button. In the window that appears, specify a safe location where the files should be saved. In our case, this will be the Mac Mini's local storage drive. Remember the most important rule. To avoid damaging the data, never save recovered files back to the same RAID array you were working with. Once the copying process is complete, you will have full access to all recovered files in the specified directory. As you can see, losing access to storage spaces software arrays or BitLocker encrypted volumes in Windows Server 2022 does not mean your data is lost. With Hetman RAID Recovery, you can easily overcome system errors, automatically rebuild a damaged RAID array, and recover all the information you need. A major advantage is the program's full cross-platform support, which allows you to work safely with server drives in a convenient environment such as macOS. If you found this video useful, be sure to like it and subscribe to the Hetman Software channel so you don't miss our new technical guides. Leave your questions or suggestions in the comments below the video. We're always here and ready to help. Thank you for watching, and see you in the next videos.